right, good morning functions. We've already kind of started to talk about the horizontal line test, but we are going to go ahead and look into the definition and go through it a little bit further. So when we talk about the horizontal line test, basically what it's telling us is if we are looking at a graph of anything, of a function, that if we do a horizontal line test, just like we would do a vertical line test to see if it's a function, we're going to do a horizontal line test, and if it passes the horizontal line test, then that means that its inverse is a function. So that is basically what that says. So go ahead and get that in your notes, and we're going to go through it. So if we look at these two graphs, like I said, we've got a negative leading coefficient parabola, and it looks like a square root function. So we've got a quadratic and a square root function. And if we were to do that horizontal line test, it crosses here and here, which means that its inverse would not be a function. So not 1 to 1. This one does pass, so this one would be 1 to 1. So go ahead and get these examples in your notes so that you can see what they look like. Make sure you hit pause. Now we're going to find the equation of an inverse of a function. So we've done a table, we've done a graph, and we've done, what else have we done? Points, right? Where we switch the x and the y to find the inverse. Well, that's going to be no different when we're solving algebraically. So go ahead and get these steps down in your notes. Go ahead and hit pause right now. So one of the things that I want to point out is this right here. You need to make sure that you're using that inverse function notation. So you need to replace that y equals with that inverse function notation. All right, so we're going to decide whether or not it's 1 to 1, and then if so, we're going to do it. Well, this is a line, so this, so it's a non-vertical line, meaning it goes like this. So that means it does pass the horizontal line, and it is a 1 to 1 function. So the first thing we're going to do is that step 1, we write it as a y equals. Then we switch the x and the y. That is step 2. Step 3, we're going to solve for y. So I'm going to add 4 to both sides. Then I'm going to divide by 3. I end up with y equals x plus 4 over 3. But I have to write it in inverse notation. So I'm going to rewrite that as the inverse of f of x is equal to x plus 4 over 3. Make sure you hit pause. Make sure you get this in your notes. We are going to do another example. All right, so we have f of x is equal to x cubed plus 1. This is a 1 to 1 function, so we are going to rewrite that as a y equals. So y equals x cubed plus 1. We go ahead and switch the x and the y. Subtract 1 from both sides. So what I did here is to get the y, move it over, if we subtract, because this is an equal sign, and if I subtract 1, I can actually put this right here. So I just rewrote it so that it's ordered correctly. Remember, this is an equal sign. And then to undo a cube, you use cubed root. So to undo any power, you use that power's root. And make sure it's the whole thing is underneath that root. We write it as y equals the cube root of x minus 1, which actually is the inverse of f of x is equal to the cube root of x minus 1. We can also do this one. Even though this function is not 1 to 1, we can find the inverse. And we want to rewrite it. Oh, this is the one that I need to write out. So hold on, let me grab my thing. Okay, so to do this one, you got to rewrite it as a y equals. The next thing I'm going to do is switch the x and the y. So I end up with x is equal to y minus 3 squared. I'm sorry, I put cube for some reason, squared. Okay, so we want to do reverse PEMDAS to solve. So the first thing I need to do is I got to break this out of its parentheses before I can start moving these apart. So the first thing I'm going to do is I'm going to take the square root of both sides. And I end up with, right over here, the square root of x is equal to y minus 3. I'm going to add 3 to both sides. And I end up with the square root of x plus 3 is equal to y. And I'm not finished. I've got to rewrite it in inverse notation. I'm going to go ahead and rewrite it with the y equals first. So I'm going to say the inverse of f of x is equal to the square root of x plus 3. All right, If you have any questions, please let me know. Otherwise, I hope you have a great day. This was the last thing that we were learning. You should be able to do all of the homework now. So you should have part 1 and 2 finished. You should have the division finished. And then parts 3 and 4 cover everything that we've learned in the last week. Remember, the test is on Friday, and I will see you all later. Thank you.